Welcome to Mr. Baker's House of Knowledge.
Yay! We're here at Mr. Baker's House of Knowledge learning about triangles and cool things about triangles. One of the coolest things about a triangle, I don't know if it's the coolest, but it's one of my favorites, is the whole idea of the triangle midsegment theorem. So the triangle midsegment theorem basically states if you can identify two midpoints of a triangle, of sides of a triangle, and you can connect those two midpoints, you will have a midsegment. So what I'm saying is, if AD is congruent to DC, that made D the midpoint right here, and if CE is congruent to EB, you made E the midpoint here, then this line, DE, is a midsegment. Now, a midsegment has several properties, and that's all the then stuff. I say several, and when I say several, I mean two. Two things occur when you have a midsegment. The midsegment is parallel to the third side. So if I know something is a midsegment, then it will be parallel. So I could say DE parallel to AB, and the reason, triangle midsegment theorem. So DE parallel to AB, why? Triangle midsegment theorem. And also there's some sort of numerical relationship. It will always, the midsegment will always be half the length of the other segment. So that gives us the formula, DE is equal to 1/2 AB. By the way, I could also express that as 2 times DE would equal AB. Those are really just two ways to say the same thing, that this line is half of that line, or this line is twice as long as that line. And that's it. That's the triangle midsegment theorem. It's just that easy. So what we're going to start looking at is we're going to start looking at ways in which we apply the concept of the triangle midsegment theorem. Say that with me. 1, 2, 3. Triangle midsegment theorem. Yeah. All right. So here in this top thing, let me make this a little bit bigger so we can see it. In this little top example up here, what I've done is I've created all three midsegments in the triangle. I've identified all three midsegments. And now I want to write pairs of parallel lines. I want to recognize which lines are parallel. Why is it important to recognize when lines are parallel? What really cool happens when you have parallel lines? They don't touch. That's the definition of a parallel line. What else can occur? Let's say you have parallel lines and some lines going through them. What else then happens? What's congruent? Right, we got alternate interior angles are congruent, corresponding angles are congruent. What about when you have two parallel lines cut by a transversal? What about the same side interior angles? They become supplementary. I mean, there are all sorts of things that occur when you know that two lines are parallel. So that might be really important information, is to be able to identify when lines are parallel, other than me just saying, hey, these two lines are parallel. Now we've got some ways that we can claim, without me just flat out straight telling you lines are parallel, now we can find out they're parallel. So in this case, because RT was a midsegment, RT is parallel to EF. And since RS was a midsegment, RS is parallel to DF. And since TS was a midsegment, TS is parallel to DE. How did we know TS was a midsegment? Because it connected two midpoints. How do we know these are midpoints? Because this is congruent to that. That means that's a midpoint. And this is congruent to that. That means that's a midpoint. Pretty neato, huh? All right, so what I want you guys to do real quick, let me go ahead and kind of enlarge this where we can see it a little bit better, is I want you to take a look at this right here. And I want you on a sheet of paper to go ahead and tell me the lines that would be parallel based on this information. I'll go ahead and white out this other stuff that's kind of in our way so that it won't be bothering us as much. And what I want you to do is I want you to be able to tell me which lines are parallel lines. I'll give you a hint. It might be a good idea to make a sketch of the triangle. All right, so hopefully you were able to get with your partner and you were able to decide what the parallel lines were. Probably the way I would have started this is I would have drawn a triangle. I would have labeled it X, Y, Z. And then I would have gone in and put the midpoint. So A is the midpoint of X, Y. B is the midpoint of Y, Z. And C is the midpoint of ZX. And then I would have connected those mid-segments. And then to me it's pretty easy at this point how to determine what's parallel to XY, what's parallel to YZ, and what's parallel to XZ. So what is parallel to XY? CB, or BC. What is parallel to YZ? CA. And what is parallel to XZ? AB. Everybody okay with that?
What if you labeled your triangle a different way, and you still it was still the same concept?
No matter how you label your triangle or how you draw your triangle, A should always have been the midpoint in between those two, and C should have always been the midpoint between those two. So that line will always be parallel to that line. So I'm not so concerned about the specifics of this, but the specifics of this need to be consistent. We good? All right. Next task. Part B is dealing with this particular picture right here. And I'm even going to go ahead and put some extra information on it. So I want you to tell me not only what the measure of angle VUO is, but if I tell you that angle M is 90 degrees, I want you to tell me what angle O is as well. So work on that by yourself first. Then we'll discuss it with our partner, and then we'll talk about it with everybody. So remember, I'm telling you that this angle right here is 90 degrees. I want the measure of angle VUO, and then I want the measure of angle O. All right, the fact that this is a midpoint and this is a midpoint lets me know that this is a mid-segment. If it's a mid-segment, those two lines will be parallel. If those two lines are parallel, corresponding angles are congruent, that measure comes out to be 65. And then this measure would also be 90. So now we have two of the three angles we need. To find out the missing third angle, we just add these two together and subtract it from 180. So 180 minus 65 plus 90 added together is 180 minus 155, which would come out to be 25. So the measure of angle O is 25 degrees. So we're starting to still use stuff that we've used in the past. All of this stuff kind of starts to fit together. All right. The next thing I want to talk to you about, let me make this a little bit bigger so we can see it, is the types of equations that can be formed by knowing that stuff is a mid-segment. So if I know that T, B, and U are all midpoints, then TU, UB, and TB are all mid-segments. And yes, that means that a mid-segment is parallel to the third side, but it's also half the length of the third side. So I could find out that TB times 2 is going to equal QR. And TB is 30, so 2 times 30 would equal 60. So maybe if I've got the smaller mid-segment, I'm multiplying it by 2 to get to the third side. Or if I have the third side, I'm going to divide it by 2 to get the mid-segment. So in the case of QS, QS is equal to 50, but its mid-segment is 25 because half of 50 is 25. Or SR is 40. That would make the mid-segment that goes with it 20. So you can either multiply the shorter side by 2 to get the longer side, or you can divide the longer side by 1/2 to get the shorter side. So that's what I want us to do right here is I want you to go ahead and use this drawing and this information. I want you to go ahead and set up an equation, and then after you set up the equations, you should be able to tell me these values. But I want to see the equation you use to determine those values. So go ahead and get working on that. If you're watching the video, pause it. So I think the way I would have approached it is I probably would have started with the first line segment that they wanted to find the value of, which is DC. So DC is equal to AD because they are marked congruent. And it said in our problem that AD has a value of 6. So that equation is pretty simple. Segment DC is equal to 6. So that's your first answer right there. I would probably use the segment addition postulate to say that AD plus DC is what's equal to AC. Remember, we have something called the segment addition postulate. I don't need to put the lines over these if they're equal. We have something called the segment addition postulate that lets us add 2 segments together to get the longer segment. And if you noticed, I erased those things. The reason I erased them is because you don't put the line segments over them when they're equal to each other. That's notationally incorrect. So I wanted to correct myself. So by substituting, we already know that AD is equal to 6. We already know that DC is equal to 6. And 6 plus 6 is 12. So we can find the value of AC as 12. So we've got AD is equal to 6. AC is equal to 12. EF is the mid-segment of AC. So EF is going to equal 1/2 of AC. So that's 1/2 of 12, which is 6. And then DE is the mid-segment of AB. So AB will equal twice DE. So that's twice 7.5, which comes out to be 15. Now, make sure you understand why I multiplied by 2 over here, but I multiplied by 1/2 over there. You got to know when to do what. Does anybody have any questions? Yes?
So you have to write up this.
This is what I would call showing your work. Some of us are having a little bit of an issue of showing our work on notebook checks. So, yeah. I just thought I would illustrate that. All right. Last thing I'm going to talk to you about today. Practicality. So here we have a story about a geologist who wants to determine the distance across a sinkhole. Now, he can't physically walk across the sinkhole carrying a measure tape or rolling one of those little things that like rolls and measures distances because he'll fall into the sinkhole and die. We don't want that to happen. So we're actually going to use some geometry techniques to find the length of a value that we cannot physically measure. And when we start doing trig later, we'll be doing a lot of stuff that you can measure stuff that technically you couldn't physically measure. Like we can't measure the distance from the Earth to the Sun by physically, looking at the odometer on our spaceship and flying there because we would burn up. But there are techniques that would give us an accurate distance. So what I'm going to do here is let's say I start at point D and I go to point C and I know how long these two things are. And I walk to a point, or maybe probably even better is I would start here and I would walk to where I get to a point where I want to start measuring one side of the triangle, and then I'd walk this distance over here and stop so that I know how long this distance is and I know how long this distance is. And then on this side, I just keep going the same length as this distance. And over here, I just keep going the same length as this distance. And then I can actually measure this distance because I don't have to walk across the sinkhole. So I can get this distance measured. And I also notice that since I created this line from the mid-segment of a triangle, then this line is going to be half the length of this line. So I do 46 times 2, which is 92. And that's how I find the length of this line. Does that make sense? All right, so what I want you guys to do is I want you guys to use those techniques and come up with a solution for the length of the bridge in this particular picture right here. So I'm going to take a picture of it, make it a little bit bigger. And there you go. So I want you to work and find the length of CD based off of this diagram right here. Hopefully you were able to recognize that since these two things right here marked congruency, that D was a midpoint, and the same thing, since these values are the same right here, then C would be the midpoint. That makes CD a midsegment. So CD is actually going to end up being equal to 1/2 of the third side, which is 2640. So 1/2 of 2640 would be 1320 feet. That's all you got to do.
I forgot feet.
All right, so knowing that you have a mid-segment lets you measure this length right here, take half of it, and then you can determine the mid-segment. Does anybody have any questions?